One thing which you have to keep in mind and which I have not been telling correctly in those past slides is that I was using equilibrium precipitate as an example for hardening, but in reality particularly in aluminum copper alloy it is not the equilibrium precipitate, but some metastable precipitate which really cause the hardening. So, the precipitation sequence is precipitation sequence in aluminum copper alloy is that initially some precipitate known as GP zones form, which then transform into theta double prime, then they transform into theta prime, and finally only they form theta, which is the equilibrium precipitate. Whereas all these three are metastable precipitate. And in fact, real cause of hardening are these metastable precipitate. It is the initial formation of GP zones which leads to hardening. However, we do not want to get into the details of this in the present course. I have assumed, but wrongly so, that theta was the precipitate which was causing equilibrium, but the basic principles which we taught about, that how the precipitate causes obstruction in the motion of dislocation, how they come and how they are related to the phase diagram and the TTT diagram, some of those principles are applicable to the metastable precipitate formation and the hardening mechanism which will be true.